All right. Hi again, guys. So, to start our very first part of this, after we've done some polynomial review to look at quadratic equations, we are going to be experts or become experts at looking at all of the different forms of quadratic equations. So, our first one that we're focusing on is vertex form. And we know what vertex form looks like. We've talked about, like in this example, that they say f of x is the same thing as y equals, right? X minus something squared plus something, where the vertex then would be this hk. So it's like x minus h squared plus k. So in this case, the vertex is 2, 1, because we want this to be a minus and want this one to be a plus right here. So we've seen that before. We know what vertex form is. We need to be able to do a whole bunch of things in vertex form, including graphing it. And the biggest focus of this unit is solving it, meaning find what x is. Find where the parabola hits the x-axis. Find its roots or its zeros. That's the hardest thing to do for all of these quadratic equations. So we're going to look at how we would do that today. First step, graphing it. Okay, if we know that it's in vertex form, we know the vertex, right? That's what we're going to start off with. So in this first example, they actually started with this first. And they said, hey, the vertex is 2, 1. And we put it on the graph, 2, 1. And then to find the other points, guys, that's literally it. We're going to find other points. We're going to plug in things that are close to where the vertex is so we can get some points that are nearby. We're not going to plug in random points, especially like I wouldn't plug in 10 for this because it's going to be way up here. It's going to be something that's ungraphable. So if we pick x's that are close to the x of the vertex, we're hoping that we can probably fit them on a graph. So they picked one, plugged in one, did the work, and they got what y would be. They picked 0, and then they went higher and higher and stayed pretty close to the x and found the new points. That's all we're doing for this one. So let's try number 1 on our own here. Here's our equation. Is this in exactly vertex form right now? No, this is not. I'm actually going to zoom in here, guys. Okay, because this means it should be minus right here. So the vertex here is supposed to be a -3, comma, and this one should be plus. So this is going to be -2. That's our vertex in this case, because this one should be negative, this one should be, or this should be minus, this one should be plus. So we've got to do the opposite of both of them right there. So I'm going to start with our vertex, -3, -2. That's going to go in the middle. So every time on the table, start with that. Let's graph it. -3, -2. There's our vertex. Which direction is this going to open? We can tell that from vertex form. There's no a. The a in front of it is just 1, a positive one, so it must be opening up here. But let's find some exact points. So we're going to say, all right, let's go smaller and larger than -3. Smaller would be -4 and -5. Larger would be -2 and -1. Let's plug in some of these values and see what we get. So for -5, here's my work. Y equals, or f of x equals, parentheses, -5 plus 3 squared minus 2. And I am going to have you write out this work. Later on, you can get good at checking it in your head, but for the test, I would want to see how you're getting these points. All right, now I can simplify what's in the parentheses first. -5 plus 3 is -2. So what's -2 squared minus 2? -2 squared, -2 times -2 is +4. Minus 2 is just going to be a +2. So when x was -5, f of x, or y, was a +2. So is that graphable for us? -5, +2, yeah, it's right by the hole, but it's graphable. Let's see what it is when it's -4. So y equals, or f of x equals, -4 plus 1 squared, plus 3 squared minus 2. And then that's going to be -1 squared minus 2, which would be 1 minus 2 is -1. -1 right here. Can we graph that? -4, -1. We've got that on there. Okay, and then you can continue. Here, I'll finish this one example with you. What if we plugged in -2 and 1? So -2 plus 3 squared minus 2 would be 1 squared is 2. 1 squared is 1, minus 2 is, hey, -1 again. Oh yeah, because this was the vertex. So if we go on either side, shouldn't we be seeing symmetry? So here, -2, -1. What do we expect this one to be then? Hopefully it's going to be 2. Let's find out. We're plugging in -1 plus 3 squared minus 2. So that's going to be 2 squared minus 2. 4 minus 2 is 2. And there we go. So by doing them both, it's going to be your check that you're not making any silly mistakes on one of them, because it should be symmetric on either side of this vertex if you're just counting by ones right here. So when we draw this picture in, we're going to make sure that we show that it looks like it's curved here. Make sure it doesn't make a V because it doesn't go straight down there, but it's curved, and make sure you're showing arrows that it's going on forever in that direction. Okay. So I'm going to have you guys, I can write the vertex here too. Forgot to do that. I'm going to have you guys try the other 3 examples on this page to make sure that you've got it. And then actually I am going to have you pause the video. And then when you are all done, unpause it, and I will show you the answer key on the video so that you can check it. So right now, pause it. Don't come back until you are all done with 2, 3, and 4. Okay. I hope you're all done with 2, 3, and 4. I'm having you be honest right now because here is what I'm going to have you check. The vertex for 2 should have been -1, 4 for that one. And this had a -2 in front of it, so it was opening down for sure. And when you did all the work, these are the points that you should get. -3 down here, -4, -2, +2, and then 0, +2, and 1, -4. Okay, and if you didn't, you can go back and you definitely want to look at your work. Number 3, the vertex is 2, -1, because that should be a plus right there. And then when you go on either side of it, I got 0, 7, 1, 1, and then 3, 1, and 4, 7. So it looks like this. It was a +2, so it was opening up. And then this guy, no number out in front, so that A was 1, so it's going to be opening up because it was a positive. Our vertex is going to be a 4 because we want that to be a minus, so that's 4. This one we want to be a plus, so our answer, or part of our vertex, is going to be the -5 right there. 4, -5. And then the other ones were 2, -1, 3, -4, and then again 5, -4, and 6, -1. So that's what they should look like for you if you have mastered graphing from vertex form. All right, your next task, now that you are masters at graphing from vertex form, is, let me go back to our packet here, we are going to look at page 6 and 7. So the next 2 pages, this teaches you how to actually find the x-intercepts from vertex form. So we're finding the x-intercepts, or I think I might have talked to you about this before, that the x-intercepts are also called the roots or the zeros of a quadratic equation. Whenever we're finding those, that's what it means to solve a quadratic. Find the x-intercepts. And remember, often there's 2 different x-intercepts depending on where it hits. So if it's a parabola that crosses twice, there's 2 x-intercepts. Could it just cross once? If the vertex was the x-intercept? Sure. Could it have no x-intercepts? Yeah, if it's something like this maybe, where it doesn't even go near, or up here, it doesn't go near the x-axis. So it could have 1, 2, or no x-intercepts. You can't have 3. It's not going to turn and come back down. But all of those are possibilities. So our job is always to find those x-intercepts when we're trying to solve. So it's called a root or a zero. The x is called the root or a zero when y equals 0. So that's going to be the key of solving today, is we're trying to find x, the x-intercepts. That is when y equals 0 is the x-intercept. Right? Since y equals 0, the roots are the x-intercepts. That's what we've talked about. To find them, plug in y equals 0, and we're going to solve for x. When it is in vertex form, this is something you can do by just doing things to both sides of the equation. So we've been working with the vertex form. Can we find the y-intercepts? Look at this first example. Here was my y. If I want my x-intercepts, my roots, I need y to equal 0. And then our job is to get x by itself. So we're going to follow undoing parts of this equation to get that x by itself. So I've got to get rid of this minus 4 first. That's got to go. To get rid of minus 4, I add 4 on both sides. And this is what I'm left with now. 4 equals x minus 6 squared. I can't get rid of that minus 6 right now because it's within the parentheses and it's being squared. But I can get rid of the squared. How do I get rid of squared? What's the opposite of squaring? The square root. If I take the square root of this whole thing, the square root and the squared cancel out because they're opposites. Whatever I do to one side, though, I have to do to the other, so I take the square root of 4. Now, in doing this, look what happens on the left. Square root and squared cancel, and I have x minus 6. On the right, this is where we've got to be careful, because what is the square root of 4? 2 is usually what we think of, but couldn't it also be negative 2? Isn't negative 2 times negative 2 4? So here's our symbol, that 4, the square root of 4, could be either positive or negative 2. Right there, and that's how we would write it. So to continue on here, the very last step to get the x by itself would be to get rid of now this minus 6. So when we add 6 to both sides, we end up getting 2 different possible answers, either the plus or the minus, the negative 2. So if it was plus 2, positive 2, we would get positive 2 plus 6, and you'd get x equals 8. If this was negative 2, you'd get negative 2 plus 6, and x would equal 4. So those are both possibilities. If you get those, it means it hits it twice. It's going to have 2 x-intercepts when x is 8 and x is 4. So the actual x-intercepts as ordered pairs, the roots, would be 8, 0, 4, 0. That is the x-intercept. So this one I'm going to have you look at. This one gives us ones that are not whole numbers and asks you to look at how to do that. These we got lucky because they were nice whole numbers. This one I'm going to have you look at, and then once you look at that, I'm going to have you guys do the practice on page 7 for you guys to look at. All right. So look at this one, pause the video, do all the practice on page 7, and then you can come back and start the video again, and I will show you the answer key for any of them that you were stuck on. All right, so pause and go try it. All right, I'm going to show you the key. I've got it in a different packet right here. I will tell you guys that 2 was the only kind of nice one. I want to show you that one first. With 2, I plugged in 0 for y, added 8 to both sides, but here you had to get rid of this 2 times it first. So that is a little bit tricky. I'm going to leave this up if you feel like you need to pause it and see what I did, dividing by 2 on both sides. Then I took the square root on both sides, and I got positive or negative 2 again. And I ended up with 2 different roots right here, 4, 0, 0, 0. If you want to look at that one, go ahead and pause. And I'm going to go on to look at these other ones, 1 and 3. Number 1 ended up being pretty straightforward, where you'd add 5 to both sides, take the square root of both sides, but 5 doesn't have a nice square root. So all we can say is plus or minus the square root of 5 right there. And when we get an answer here, x is either going to be the positive square root of 5 plus 4 or the negative square root of 5 plus 4. That's all we can do to it. Or you could change the order of this around and say 4 plus or minus the square root of 5. But that would be what our roots would look like. So if you want to take a moment to pause it, you can do that. I'm going to move on to number 3. Number 3 was another one where once we subtracted 4 from both sides, we did have to divide both sides by negative 2 first before you could take the square root. So then we take the square root, we get positive or negative square root of 2. That's not a nice number, so we just leave it as a square root of 2. It's not rational. And then you end up with x equals positive square root of 2 minus 1 or negative square root of 2 minus 1. And that would be our roots right there. Okay, or you could change it around to be negative 1 plus square root of 2, negative 1 minus the square root of 2, either way. And number 4, okay. Sorry if this made you mad. I really wanted you to look at this and see what happens. When I had this plus 1, I subtracted 1 from both sides, and you do the square root of negative 1. What I needed you guys to realize was not possible. There is no real number square root of -1. So in this case, because we got stopped, we couldn't find an x-intercept for this, it means it doesn't exist. This would be one that doesn't hit the x-axis. It doesn't have an x-intercept. It's either opening up or opening down somewhere far away from the x-axis and doesn't cross it. So now you see how we would know if it doesn't have an x-intercept. We'd get something that was impossible to do. All right, great job, guys.